Have you ever pondered what makes our sun and countless other stars in the universe shine so brilliantly? The answer lies in the fascinating journey of main sequence stars. The life of a main sequence star, like our very own sun, is a cosmic dance of energy, fusion, and gravity. It all begins in a nebula, a giant cloud of dust and gas in space. Within these nebulae, tiny particles begin to clump together under the force of gravity. Over millions of years, these clumps grow larger and larger, forming a protostar. This protostar continues to grow. And as it does, gravity pulls more and more material inward, raising the pressure and temperature at the core. When the core temperature reaches a staggering 10 million degrees, the stage is set for the birth of a main sequence star. At this critical temperature, hydrogen atoms in the core start to fuse together to form helium, releasing a colossal amount of energy in the process. This is nuclear fusion, the power source of stars. This energy radiates outward, producing the star's light and heat. The star now enters the main sequence phase, the longest stage in a star's life. It's during this phase that a star shines most brightly. For our sun, this phase has lasted about 5 billion years, and it's expected to continue for another 5 billion more. But eventually, the hydrogen in the star's core runs out. When this happens, the core contracts under gravity, causing the temperature and pressure to rise once again. The helium now begins to fuse into heavier elements like carbon and oxygen. This new phase of fusion causes the star to expand dramatically, becoming a red giant. The fate of the star now depends on its mass. Stars like our sun will shed their outer layers, leaving behind a white dwarf, a hot, dense core. Larger stars, however, will experience a more violent end. Their cores will collapse under gravity, leading to a supernova explosion, leaving behind a neutron star or even a black hole. So, what have we learned about main sequence stars? Their lives begin in the cold depths of a nebula, growing from tiny clumps of dust and gas into protostars. Once their cores reach a critical temperature, they ignite in a blaze of nuclear fusion, entering the main sequence phase. During this phase, they shine brightly, powered by the fusion of hydrogen into helium. But nothing lasts forever, and eventually the hydrogen runs out. Depending on their mass, they will either become a white dwarf or explode in a supernova, leaving behind a neutron star or a black hole. Main sequence stars, then, are the powerhouses of the universe. They shine brightly, fueling life on planets like ours, and their explosive deaths create the heavier elements that make up worlds and beings. They are, quite literally, the stuff of life. Their life cycle is a testament to the beauty and grandeur of our universe, a cosmic ballet of energy, fusion, and gravity. Remember, every time you gaze up at the night sky, you're witnessing this cosmic dance of life and death, a spectacle that has been unfolding for billions of years. And it's all thanks to the life cycle of main sequence stars.